Okay, this video is on rotations, and a rotation is just a transformation in which we turn a figure around a fixed point. And in this case, our fixed point is always going to be the origin. So if you can kind of imagine, you have a set of x, y axes here and a figure, this triangle. And if you can kind of imagine a pin stuck in the origin, and we're going to rotate the figure around the origin. So basically what we're going to do is you can kind of take your notes, take your paper, and just turn your paper 90 degrees clockwise. So example 1 is rotating 90 degrees clockwise. So if I turn my entire set of axes, my xy axes 90 degrees clockwise, this is what my rotated figure looks like. So after I've rotated my figure, now this axis here is going to be my x-axis. This axis here is going to be my y-axis. So after I've rotated my figure, I can write down what my new coordinates, the new coordinates for each of my vertices is going to be. So this coordinate right here is going to be x1, y1. So this is going to be a prime. That's going to be 1, 1. In fact, let me write it up here. A prime, right here. A prime is going to be 1, 1. And let's see, b becomes b prime. So b prime is going to be, let's see, 1, 2, 3, 4, negative 2. B prime, 4, negative 2. And c prime, c becomes c prime, which is going to be, let's see, 1, 2, 3, negative 4. So c prime is 1, negative 4. All right. Now I want to turn back to my original orientation and draw in my rotated figure. So let me go back to my original orientation of my axes, and let me draw in my new a prime, b prime, c prime triangle. So let's see, a prime is at 1, 1. So that's going to be right here, a prime. B prime is going to be at 4, negative 2. So let's see, 1, 2, 3, 4, negative 2. So here's B prime. And C prime is at 1, negative 4. So 1, negative 4. And here's C prime. So if I connect up these vertices, then I have my triangle A prime, B prime, C prime. And you can see that it looks like I've taken this triangle and I've rotated it 90 degrees clockwise. So let's draw, or let's write down our vertex matrices, my original vertex matrix and my transformed vertex matrix. And these are my x's on top, my y's on the bottom. So my original triangle is negative 1, 1, 2 and 4, and 4 and 1. My rotated triangle, let's see, A prime is 1, 1. B prime is 4, negative 2. And C prime is 1, negative 4. All right, so there's my vertex matrices. Now I want to come up with the algebraic rule that represents this transformation, this rotation of 90 degrees about the origin. So let me see. If I look at my original vertex matrix and my transformed vertex matrix, well, first thing I notice is that my original, let me go ahead and start this here, x, comma, y. So the first thing I notice is that my new x values in my transformed matrix are exactly the same as my original y values. So my new x values here are just going to be my original y values. And my new y values after my transformation, well, they look like my original x values, except they're all negative. So if I take the negative of my original x values, that becomes my new y values. So the negative of my original x values, that's my new y values. So now I have my algebraic rule, xy becomes y, comma, negative x. All right, let's take a look at a rotation in which now this time I'm going to rotate clockwise 180 degrees. All right, so again, I've got the same triangle that I started out with. I got my set of XY axes. I'm going to rotate it 180 degrees about the origin. So again, I'm going to take my whole page here, my whole board, and I'm going to rotate it 180 degrees. So if I rotate it 180 degrees, now my rotated figure is going to look like this. This is my x-axis and this is my y-axis. And so once again, I just want to write down all my three different coordinates, set of coordinates for each one of my vertices. So let's see, A prime is going to become this point right here. So A prime is going to be 1, negative 1. B prime is going to become negative 2, negative 4. And C prime is going to become 1, 2, 3, negative 4, negative 1. All right, now let's go back to our original orientation and we'll draw in those coordinates on our original set of axes. So let's see, A prime, I kind of have to read upside down. A prime is 1, negative 1. So let's see, A prime becomes this point right here. 1, negative 1. B prime is negative 2, negative 4. Negative 2, negative 4. So here's B prime. Negative 2, negative 4. And C prime is negative 4, negative 1. So 1, 2, 3, negative 4, negative 1. And here's C prime. Negative 4, negative 1. So I've got my three vertices. I just connect up my vertices. And here is my figure, my original figure rotated 180 degrees clockwise. So now I just need to write down my two vertex matrices. My original vertex matrix, it's the same one it's always been, which is negative 1, 1, 2, 4, 4, 1. X is on top, my Y is on the bottom. And my new vertex matrix, A prime, B prime, C prime, is, let's see, A prime is 1, negative 1. B prime is negative 2, negative 4. C prime is negative 4, negative 1. All right, so now I have my vertex matrices. Now I want to come up with my algebraic rule. So let's look at the vertex matrices and see if we can come up with the algebraic rule. So let's see. It looks like my x's on my new vertex matrix, it looks like my x's are the same as the original x's, except they're all negative. So my new x's are just the negative of my original x's. And let's see, it looks like my new y's are also the negative of my original y's. So my algebraic rule is just going to be xy transforms into negative x, negative y. All right, let's try one more. Example number 3, I want to take this same figure, and this time I want to rotate it 270 degrees clockwise. So let's go ahead and take this. Let's go 90 degrees, 180 degrees, and 270 degrees. All right, so now, and I think some of this may be up off the top of the screen here. Now I've rotated this 270 degrees, so once again, I've got my x-axis here, my y-axis is here, and now I just need to write down the coordinates for my rotated figure. So here's my new A point, my A prime. A prime becomes, let's see, this would be negative 1, negative 1. B prime, let's see, this is B prime, so B prime is negative 4, positive 2. And C prime is up here, that becomes negative 1, positive 4. All right, so now I have all of my new coordinates. Let me put my figure back, put my paper back on its original orientation. Okay, now I've got my coordinates for all my new points, my new vertices. Let me just fill those in on my original set of xy axes. So A prime is -1, -1. So that's right here. -1, -1. B prime is -4, 2. -4, +2. So this is B prime. And C prime is -1, +4. So -1, here's C prime. -1, 4. And again, I connect up my vertices. And here is my original triangle rotated 270 degrees clockwise. So, once again, I'm going to write down my vertex matrices. My original one, my transformed one. X is on top, Y is on the bottom. My original one's the same as it always was, -1, 1, 2 and 4, 4 and 1. And let's see my transformed one, A prime, -1, -1. B prime, -4, 2. C prime, -1, 4. Now I've got my two vertex matrices. Now I just need to come up with my algebraic rule. Okay, so let's see. Let's look at the two matrices here and see if we can figure out what the pattern here is. So let's see, my new x coordinates, they look the same as my original y coordinates, except they're all negative. So my new x coordinates are going to be my original y's, just negative. And my new x coordinates, excuse me, my new y coordinates are going to be the same as, well, they're exactly the same as my original x coordinates. So my new y coordinates are just my original x coordinates. So here is my algebraic rule for doing a 270 degree clockwise rotation. Now, let's summarize each one of these three, the algebraic rules for each of these rotations. And now, before we do that, I want to point out, notice that for any type of rotation, you could either go clockwise or you could go counterclockwise. So if I go clockwise, for example, 90 degrees, that takes me this way. This is 90 degrees clockwise. Well, notice that this is exactly the same as if I go 270 degrees counterclockwise. So 90 degrees is the same as 270 degrees counterclockwise. And the algebraic rule for that is, the algebraic rule for the counterclockwise rotation is going to be the same as the one for the clockwise rotation, which I look back at my notes, and let's see, that algebraic rule is x, y goes to y negative x. 180 degree clockwise rotation is the same as a 180 degree counterclockwise rotation. And my algebraic rule for that is negative x and negative y. And let's see, a 270 degree clockwise rotation is going to be the same as a 90 degree counterclockwise rotation. And they're going to have the same algebraic rule. And I look back at my notes and I see that that algebraic rule is negative y x. So now I have all of my algebraic rules for each type of rotation that we're going to be doing. Now, in your notes you have 3 more problems that I want you to work on your own. Each one of them asks you to write down the original vertex matrix and then the transformed matrix. Notice that on 2 of those examples, you're asked to do not 1 transformation, but 2 transformations. And in those cases, you're actually going to have a vertex matrix that you start out with, you're going to perform the first transformation on it, which is going to give you a second vertex matrix. Then you're going to take this vertex matrix and perform another transformation on it. So on those problems, you're going to actually end up with a total of 3 vertex matrices. The one you start out with, the one that you have after your first transformation, and then the third one, which you have after performing the next transformation on the second matrix. So take a look at those 3 problems. I want you to work those on your own, and we'll take a look at those in class tomorrow.